Okay, here's a practice problem from chapter 20. Okay, we want to solve the electric potential, the standard value from this reaction. Okay, and notice the spectator ions are gone. So we just have the atoms and ions involved that are actually doing the reduction and the oxidation portion of this reaction. So first thing you want to do, take it and separate it into the two half reactions as it is written. So you can see that the lead is going through a reduction process and the chromium is going through an oxidation process. Okay, the reduction occurs at the cathode in the electrochemical cell, while the oxidation is at the anode. All right, now to get these potential values, this negative 0.13 volts and negative 0.73 volts, just turn a couple of pages back into your book and you'll find there in chapter 20 a reference table with electric reduction potentials. Now, when you refer to that table, those values are written as reduction potentials, not as oxidation potentials, but as reduction potentials. Leave the values as you find them. Do not change the signs. Do not flip the reactions. Okay? What we want to do is look at those two reduction values. The one that is more positive, in this case, the negative 0.13 volts, that's going to be the cathode site. That's going to be where you do reduction. Okay? So to get the standard potential, the volts, for a cell, you take the cathode, the reduction value, and you subtract the anode value. Now, if the anode value happens to be negative, then it will change the sign. You can see the negative 0.13 volts minus a negative 0.73 volts. You see that that sign flips and it becomes a positive 0.60 volts. Okay. Now, what we can infer from that final value, that 0.60 volts, since the Ecell value is positive, then the reaction as it is written will be spontaneous, which leads us to know that the delta G, the Gibbs free energy value for this reaction, will be negative.